Okay, so now the Math 161 major quiz and some major things that people did wrong. Okay, so I'm gonna do this kind of quickly because this is all stuff everybody knows. Or everybody has done well in class because as a class, people come in and do well on the quizzes. Um, I mentioned that one way to prepare for these exams is to go back and work all the quizzes. You got them at the beginning of every video. You got a quiz, you can see the statement and work it. And then if you're not confident, you can watch me work it. Okay, well, first problem, ask people to sketch a 4x4 graph. For some function. It's either going to be exponential, reciprocal function. Now, typically, most people, not everybody, but most people lined off their graph perfectly well. Okay? So, you'll have, if it's the, we'll do the reciprocal, or the squaring function. And you're going to recognize these lines. People didn't put the red dot on the graph. Why? The red dot. The red dot is the point to which the origin is shifted. When you get the function. So here's the red dot. Now that would be for the squaring function. So we'll circle this, circle quadratic, because that's the one we're actually doing here. Exponential would look a lot like this, but you wouldn't need these two lines. There's some other stuff here. Okay, so for the quadratic function, what do? We start in the upper left-hand corner, move right one, down two, right one, down two, right one, down two, and we get to the red dot. So then we do right one, up two, right one, up two, right one, up two, and here we have the points. Now I saw graphs where these points weren't even on the construction lines. Okay. So at least one graph from somebody who's been doing pretty well in the course, I thought. But this clearly hadn't been reviewed. Okay. Now, again, I say most people have the construction lines. Now, this process, I've been very specific about, you need to label the construction lines. Label everything and label it properly. Okay. Now, I'm not just talking to people in this particular group. I'm talking about the class in general because I don't remember even what any individual did. But what I saw a lot of was there's labeling. But it wasn't as precise as I'd like to see. Okay, so there's a general lack of precision in the way people are doing this. Now, what I gave you was important to this point. So let's just say the red dot is at the point 12, -14. Okay. Now that means immediately that this line here is a line x equals 12. Okay. And you want to write x equals 12. Don't want to just write 12, you want to write x equals 12. Remind yourself that that's the equation of a vertical line because people are still making mistakes. of that. Okay. Then we have the line y equals -14. That's a little sloppy there at the end of the board, but I think it's good. Okay, we write y equals -14. Then what do? Well, we label the rest of the construction points. Now, this is a 4x4 graph. I have people putting all kinds of numbers here and here, okay? Because people didn't have the red dot. Often, numbers they had here had nothing to do with the position of the red dot. And even when it did, people put wrong numbers in here. This is y equals -14, and this is a 4x4 rectangle. That means it's got to be 4 units high. If this is y equals -14, this is y equals -10. Well, now it's 4 units from here to here. -14, -13, -12, -11, which is one of the lines, -10. Now we can label the car halfway between -14 and -10, y equals -12. Halfway between -14 and -12 is 8. And I think I said something wrong a minute ago. I don't know word too much about it right now. And that's y equals -13.5. Here, and you want to make a bigger picture, probably bigger than I did. I don't really have room to label the rest of it over here, so I'm going to come over here and I'm going to say over here y equals -13 3/4. That would be this one. Y equals -13 7/8. That would be this lowest line. Okay. Then we label the x number. Now, if this is a 4x4 rectangle and x equals 12 is in the middle, then we're 2 units to the left of the right edge and 2 units to the right of the left edge. So it's 2 units to here and 2 units to here. So that this line is going to be x equals 10. This line is going to be x equals 14. Then we can label x equals 11 here, x equals 12 here, and x equals 11.5 would be this line, and x equals 12.5 would be this one. X equals, y equals. We have to put those numbers, those labels in there because that's the way I've always done it and the way I've always asked you to do it, okay? So all that is just a matter of review. Seeing that, you'd probably do it right now, okay? Then I asked for a table. Okay, and you know, I'm saying this because you're going to be asked to do this again on the midterm. And I think you're going to do it right on the midterm. Okay. If you can remember for a week or a week and a half. Okay. Or if you just review, you know, just write a little something in your notes, a little reminder. Yeah, you got to put that y equals on there again. I won't penalize it too much if you don't put the y equals and the x equals. But I'm finding that the people who put the x equals and the y equals made the higher grades. Okay, it's a matter of attention and detail. So the more attentive you are to detail, the better you're going to do. All right, now we want to get the coordinates of the construction point, these 7 x's that I made on the graph. This point is at x equals 10, y equals negative 10. This point is at x equals 11, right there's a line x equals 11, and y equals negative 13. This point is at x equals 11 and a half, and negative 13 and 3/4. The red dot is the next point, that's at 12, negative 14. And then we can list the rest of them. We get 12 and a half, negative 13 and 3/4, negative 13, negative 13. You know, when I labeled out x equals 12, that should have been x equals 13. Careless. And then 14, negative 10. There's your table for construction points. Okay. Now, what else did I ask? Well, I asked, now what's the equation of the function? The g of x equals a f of x minus h plus k. I think I left off a on this one, and I could put a under the midterm. Okay. But since it's in a 4x4 rectangle, a is 1. Always. If you use the algorithm that we've used. Now, if I made this an 8x4, 8 units high by 4, then a would be 2. And we've talked about that, but right now I chose not to test that on the data twist. Well, HK points to the red dot. You think we have toolkit function over here somewhere, we've shifted it and we've shifted it so that the origin goes to the point 12, negative 14. That means x gets replaced by x minus 12, and we add a negative 14. F of x, of course, is x squared. I expect you to know if it's a quadratic function, the toolkit function is the x squared. So this equals x minus 12 squared minus 14. And now, as you've done, as everybody's done, you make a table for this function using the x values of your construction points. So x is 10, y is 10 minus 12 squared, which is 4, and 4 minus 14 is negative 10. So it's, I'll write it out here, it's 10 minus 12 squared minus 14, which comes out negative 10. So for x equals 10, we have this calculation. I didn't leave myself room to write out the calculation, but what I'm indicating is somewhere you do these calculations and you show that this gives the same thing this does. And 11 gives you 11 minus 12 squared minus 14. It'll be 1 minus 14, so it's going to be minus 13. and then 11.5, well, do the calculations, and you get negative 13 3/4, etc. And this table perfectly matches it. Now, a lot of people wrote down an incorrect table for this, wrote down some function here, and then wrote down the same numbers here that they did here, which tells me they didn't calculate anything from the function. Okay? And that's not surprising, you're on a test, you're desperate, you try something you think might work and hope. Okay? Everybody's been there. I've been there. Okay? But usually when you do that, it doesn't work out. Okay? You follow the process. Other things that I ask here is do estimates. And then use this function to check your estimates. Okay? So for example, estimate G of 13.3. And what do I want to see? I want to see a line for x equals 13.3. Gonna have trouble labeling one, but here's 13 and here's 14. And 13.3 would be maybe about here. Just to distinguish this point and this line. Let's go it a little bit lower. Okay, so we've got this point, and we draw a horizontal line through it. And we see that it's between negative 12 and negative 13, probably a little closer to negative 12. So we write an estimate. Lines for approximately equals be about negative 12.3. Then what? Well, I say, check it out. Does it work with this function? G of 13.3 would be 13.3 minus 12 squared minus 14. Which equals 1.69 minus 14, which equals 12.31. My estimate was 12.3. I could have equally well estimated negative 12.4, and I wasn't fudging, I hadn't figured it out. But I just lucked out and estimated negative 12.3 instead of negative 12.4 and got really, really close. But there's no expectation that the graph would be accurate enough to make an estimate that close. If you use drafting tools and great precision, as some people in this class do, this class, I see a lot of really nice graphics. I'd be less surprised than I would when I get that close. Okay. So, and then of course, given a function g of x equals 13, estimate the solution of the function. So there's that whole thing. And the whole point of this is to understand translation of these functions and these rules for transformation really work. It's to convince you that there's a reality here, mathematical reality that makes sense. Instead of just a bunch of things you do without trying to, and of course, first time you do them, you just do them mechanically. But we want to pull this together. We spent a lot of time on this model. on this idea. And this should be a convincing idea. And we're saying now with polynomials, when you have a zero of a polynomial, you can get this shape. And that's zero, okay? And we just went over some of that in a different video. And you can understand the graphs of polynomials near the zeros and near the asymptotes that we're going to be talking about next week, just by understanding your toolkit functions and how they're translated and transformed. And you get a pretty deep understanding. Okay, well, I spent a good bit of time on this, but it's the one that probably deserves a good bit of time. Now, a couple of other things, and we'll talk about some things in inverse function. Inverse functions are where you swap x and y. So if you have a table for a function, the table for the inverse swaps the x and the y columns. So if you have a table, I equals f of x versus x, and you have like -3, -1, 0, 4, and your f of x has values 12, 7, 3, and -2. Then the inverse table and of course, if you're watching this video, don't wait for me to write this down, write it down yourself. What is it? Take the time to process what's going on by not sitting back and passively watching, actively engaging in what's going on. Okay. So you should write that out. But anyhow, you get 12, -3, 7, -1, 3, 0, -2, 4. I switch the x and the y columns, right? Now, if we have a function say f of x equals 5x minus 7, that generally y is the variable we'll associate with the value of f of x, we'll say y equals 5x minus 7. Swap x and y, you get x equals 5y minus 7. Solve for y, you get y equals x plus 7 over 5. Now, I had numerous people, including maybe some people in this class, who wrote the reciprocal. Okay, well, let's just, you get this. So now f inverse of x equals x plus 7 over 5. Now, people inverse of x is not the reciprocal of f of x. We're talking about the inverse function, okay? And a number of people wrote it down as a reciprocal. And it's easy to see that because you understand that the negative power gives you a reciprocal, right? But this is not a negative power of f. This is a notational, this is not an algebraic operation, it's a function. And we want to be clear about that. So that whole thing where you use the knowledge of what an negative exponent means, but this is not a negative exponent. It's indicating this inverse function, okay? So we want to be careful about that. But this is not difficult. But we have to be focused on that and what it means. Okay. Got time to look at one more thing. Okay, now, hopefully we haven't been out of focus for too long. But let me see if I can. Okay. Okay. And just in case some of this was up here, then you can freeze the screen and see what you need to see. All right. Now, one minute. Oh, yeah. Rate of change given 2 points. You plot the points on a graph. You sketch the fundamental triangle. You label run equals whatever the run equals, like, okay, this is x equals 3. This is x equals 6. Run equals 6 minus 3, which is 3. If this is y equals 12, this is y equals 5. You write rise equals 12 minus 5 equals 7. Then over here you write slope equals rise over run equals 7 over 5. Then you put 7 over 5 here in a rectangle. It's the way we've consistently done it. It's the way I've consistently told you need to do it. So make sure you do this. Because if I ask you to completely label the fundamental triangle, every error you make, other than arithmetic errors, is cost you substantially. Okay? And don't leave anything out. Label your vertical lines, label your horizontal lines, label your run equal, give the calculation rise equal, and there it is. And that's the whole story of the average rate of change of this function between those 2 points. As I've said, it's there. All the details are there. All you need is a glance. And if you follow the procedure, you know exactly where to look for everything. It's not spread out all over your page. It's not confused, because if you focus and do this, you're not going to be confused. Okay? And you're going to understand what you're doing. And on the test, I saw various levels of understanding. Okay? I had people say, well, this one changes by 12 and that one changes by 3, but never calculated the rate. Or, stuff like that. People on the verge of having it, but without the focused, absolutely correct process. Okay? Now, if you come up with something that's equivalent to that process and insightful, I'll probably be pretty lenient in grading it. But we want to get that focus. Okay?